Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have k cubed is equals to 18 cubed plus 24 cubed plus 30 cubed, and we solved this problem for all the values of k. So here now first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. And now we solve this problem for a very easy way, and we move toward the solution of this problem. So here the very first step we are going to do is first we need to focus into the right hand side. So this is 18, we write it as 6 multiplied by 3. We know that 6 times 3 becomes 18. In the same pattern, this is 24, we write it as 6 times of 4 becomes 24, and this is 30, we write it as 6 times of 5 becomes 30 and its whole cubed. And further we apply the cube and all of these exponents separately on each of these values, and it will be written as in this form. So further in the next step, when we apply this exponent both of these two terms, it will be written as 6 cubed into 3 cubed, plus this will be written as 6 cubed into 4 cubed, and this will be written as 6 cubed into 5 cubed. And now further you see here each of these terms involve 6 cubed, and when we take common 6 cubed, we get the remaining values are 3 cubed plus 4 cubed plus 5 cubed into. In the next step here we need more simplifications, and it will be written as this is a 3 cubed becomes 27 plus 4 cubed becomes here 64, and 5 cubed becomes here 125. So when we sum up all these three values, we will get here this is 216. Okay, and now further in the next step we know about that 216 becomes here 6 cubed. So in the left hand side we get k cubed is equals to 6 cubed multiplied by 6 cubed. So we write this 6 cubed times 6 cubed as 6 cubed and its whole square. So here we interchange both of these two exponents, and it will be written as a 6 square and its whole cubed. And in the left hand side we have this is k cubed. So we obtain k cubed is equals to this is 6 square becomes 36 cubed. And now here we move 36 cubed from right hand side to the left hand side, and it will becomes k cubed minus 36 cubed, and this whole equation is equals to 0. So here we apply the nice cubic formula to solve this problem. So here we use this formula. We know about that if we have a cubed minus b cubed is equals to a minus b times of a square plus ab plus b square. So according to this nice formula, we expand our above equation as in this form. So this will be written as our first factor is a minus b, the value of a is k and the value of b is 36 into this is a square becomes k square plus k into 36 plus 36 square, and this whole equation is equals to 0. So we divide this equation into the two cases. The first case is we write k minus 36 is equals to 0, and the second case is we write k square plus 36k plus 36 square, and this whole equation is equals to 0. From this case we easily get the value of k is equals to 36. This is the first real root of the given equation, and from here we use the quadratic formula to solve this quadratic equation. So for this, first we write the coefficients of this equation, and its coefficients are a is equals to 1, b equals to 36, and c is equals to 36 and its whole square. So we use the quadratic formula as minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. So here we substitute all the values of a, b, and c, and it will be written as the value of b is 36. It will becomes minus 36 plus minus square root of b square. So b square becomes 36 square minus 4 times of a is 1, and the value of c is 36 square, and it is divided by 2 times of a, and here our a is equals to 1. So further in the next step you focus inside the square root sign, and we have this is plus minus square root of, here we need to take common 36 square, and we get the remaining values are 1 minus 4, and it is divided by 2 times of 1 is equals to 2. And now here we apply the square root separately on both of these two values, and it will becomes minus 36 plus minus. When we apply square root on this value, so this square and square root are gone, and we get here 36 only into square root of this is 1 minus 4, and 1 minus 4 becomes square root of minus 3, and it is divided by 2. So here we break this fraction, and it will be written as minus 36 divided by 2 plus minus 36 times of here you know that here you see that negative sign appear inside the square root sign, so this will becomes iota, and we get here square root of 3 only, and this is divided by 2. So here we need to cancel these terms, and we obtain here this is 2 times 18 becomes 36, and we get here minus 18 plus minus. From here again we cancel these terms, and we get here 18 times of square root of 3 into iota. So these are the other two values of k, and these are the two complex roots. So finally we have there are three roots of the given equation, and these are in which these two are complex roots, and k equals to 36 be the only one real root of the given equation. So this is our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.